Dear students, welcome to my classroom. In previous class of progressions, we solved up to 10 problems in exercise 6.2, which are related to arithmetic progression. And still there are 7 more problems in that exercise. Let us complete remaining problems of that exercise today. So take the 11th one. How many 3-digit numbers are divisible by 7? The question is, how many 3-digit numbers are divisible by 7? Students, we know that the 3-digit numbers are starts from 100 and ends with 999. Starts with 100 and ends with 999. So, in these numbers, how many numbers are there which are divisible by 7? That is the question. So, the series of 3-digit number divisible by 7 is 105, 112, 117, up to 994. That is, the first 3-digit number that is divisible by 7 is 105, and the second one is 112, and like that, the last one is 994. These are the numbers divisible by 7 in between 100 to 999. Now it is asking that how many numbers are these? Okay, so by observing this sequence, we can say that these numbers are in arithmetic progression because these numbers are increasing with 7, increasing by 7. That is each term obtained by adding 7 to preceding term. So these terms are in AP. So that is common difference throughout the sequence is same. So that numbers are in this sequence are in arithmetic progression. And for this arithmetic progression, the first term is A is equal to 105, and the common difference D is equal to A2 minus A1. That is 112 minus 105, which is equal to 7. So first term is 105 and the common difference is 7. So let us consider that these numbers, number of these numbers is n. That is the number of terms in this progression be n. As we are taking the number of terms as n, the last term is the nth term, isn't it? So that nth term of this AP is 994. That is AN is equal to 994. And we know that AN is A plus N minus 1 into D. Okay. So from this we can write A plus N minus 1 into D is equal to 994. And we have A is equal to 105. D is equal to 7. So by substituting these values in this equation, 105 plus n minus 1 into 7 is equal to 994. And from this n minus 1 into 7 is equal to 994 minus 105, and which is equal to 889. So that n minus 1 is equal to 889 by 7, which is equal to 127. So that n is equal to 127 plus 1, that is 128. As the value of n is equal to 128, the number of 3-digit numbers from 100 to 1000, sorry, 999 is 128. That are which are divisible by 7 only. Okay, so the number of terms in the AP is 128. That is, number of 3-digit numbers divisible by 7 is also 128. Okay, students. So let's take the next one. That's 12th one. How many multiples of 4 lie between 10 and 250? This is also like previous problem. It is asking that how many numbers are there which are multiples of 4 in between 10 and 250. And we know that the first number after 10, which is the multiple of 4, is 12, and the last number before 250, which is the multiple of 4, is 248. So the multiples of 4 in between 10 and 250 is 12, 16, 20 up to 248. Okay, the series of multiples of 4 lie between 10 and 250 is 12, 16, 20 up to 248. So in this series also, common difference throughout the sequence is 4. That is, the common difference throughout the sequence is same. So we can say that these terms are in arithmetic progression. Now, the first term of this arithmetic progression is a is equal to 12, and the common difference d is equal to a2 minus a1, which is equal to 16 minus 12 is equal to 4. Now, let the number of terms in this progression be n. As the number of terms is n, this last one is the nth term. That is, the nth term of this progression is 248. That is, an is equal to 248. And we know that an is a plus n minus 1 into d is equal to 248. And by substituting a is equal to 12 and d is equal to 4 in this equation, we get 12 plus n minus 1 into 4 is equal to 248. And that is 2 n minus 1 into 4 is equal to 248 minus 12, which is equal to 236. And from this we can write n minus 1 is equal to 236 by 4 is equal to 59. That is, n is equal to 59 plus 1, which is equal to 60. That is, the number of terms in this progression is 60. So that the number of multiples of 4 lie between 10 and 250 is also 60. Okay, students. Let's take the next one. That is the 13th one. For what value of n are the nth terms of two APs, 63, 65, 67, and so on, and 3, 10, 17, and so on equal? Okay. Here we have two arithmetic progressions. First one is 63, 65, 67. That is starts with 63 and the common difference with 2. And in second progression, we have first term is 3 and the common difference is 7. So it is asking that for what value of n nth terms are equal in these two progressions. Okay. So for first AP, take the first AP, 63, 65, 67, so on. First term is a is equal to 63 and common difference is d is equal to a2 minus a1, that is 65 minus 63 is 2. And already we have one a value, one d value. So for the second progression 3, 10, 17, take the first term as x, which is equal to 3, and the common difference as y, which is equal to a2 minus a1, that is 10 minus 3 is equal to 7. And now it is given that for which value of n the nth terms of these two progressions are equal. That is, if nth terms of these two progressions are equal, what is the value of n? Okay. So if nth terms of these two APs are equal, so that is first nth term in first progression is equal to nth term in second progression. That is, a plus n minus 1 into d is equal to x plus n minus 1 into y. So a plus n minus 1 into d is the nth term of first progression. X plus n minus 1 into y is the second term of first term of second progression. So now by substituting the values of a, d, x, and y in this equation, we can write 63 plus n minus 1 into 2 is equal to 3 plus n minus 1 into 7. That is 63 plus, by multiplying 2, we get 2n minus 2. And here also 3 plus n minus 1 into 7 is 7n minus 7. So by taking all n terms to one side, we get 7n minus 2n is equal to 63 minus 2 minus 3 plus 7. That is 5n is equal to 65. So n is equal to 13. So the 13th terms of these two progressions are equal. Okay. That is, if the nth terms of these two progressions are equal, then n is equal to 13. So let's take the 14th one. Determine the AP whose third term is 16 and the seventh term exceeds the fifth term by 12. So here we have two hints to write the progression. That is, the third term is 16 and the seventh term exceeds the fifth term by 12. These two are the hints to find the arithmetic progression. So to write any arithmetic progression, we need its first term and common difference. So, but here we don't know the values of A and D. So let's take that A be the first term and D be the common difference of our required arithmetic progression. Now it is given that third term is 16, that is A3 is equal to 16. And we know that A3 is A plus 2D. So we can write here A plus 2D is equal to 16. Take it as equation 1. And the second hint that is given is seventh term exceeds the fifth term by 12. That is A7 is A5 plus 12. Seventh term is 12 more than fifth term. That is A7 is A5 plus 12. So also we have A7 is equal to A5 plus 12. And we know that A7 is A plus 6D and A5 is A plus 4D. So we can substitute that values in this equation. A plus 6D is equal to A plus 4D plus 12. And by transforming the terms A and 4D to left side, we get A plus 6D minus A minus 4D is equal to 12. And plus A minus A will be cancelled. And 6D minus 4D is equal to 2D. So we remains with 2D is equal to 12. And from this we can write D is equal to 12 by 2, which is equal to 6. And students, now substituting this D value in this equation 1, we get the value of A. That is, substituting this value in equation 1, A plus 2 into 6 is equal to 16. That is, A plus 12 is equal to 16 and A is equal to 16 minus 12, which is equal to 4. So now we have the values of A and D. So the first term A is equal to 4 and the common difference is D equal to 6. So the progression is, first term is A equal to 4 and the second term is D is equal to 6. That we have to add 6 to first term. That is 4 plus 10, 6. And similarly, 10 plus 6 is 16 and 16 plus 6 is 22 and so on. This is the our required arithmetic progression. Okay, students. So let's take 15th one. Find the 20th term from the end of the AP 3, 8, 13 up to 253. So in this arithmetic progression, we have to find the 20th term from the end, not from beginning. Here it is from beginning, we can write easily A plus 19D. But here we need 20th term from the end. Here we don't know the value of, we don't know the number of terms in this progression. So first we have to find the number of terms in this progression. And after that, we can find the 20th term from the end. So given AP is 3, 8, 13 up to 253. In this AP, we have first term is A is equal to 3 and the common difference D is equal to A2 minus A1, which is equal to 8 minus 3 and is equal to 5. So let us find the number of terms in given AP. And consider the number of terms in given AP be n. As we are taking the number of terms as n, then the last term 253 is the nth term of given AP. That is, an is equal to 253. And we have an is equal to a plus n minus 1 into d. So that by substituting with the values of a and d is in the equation, 3 plus n minus 1 into 5 is equal to 253. And from this we can write n minus 1 into 5 is equal to 253 minus 3. That is 250. And n minus 1 is equal to 50 by 5, which is equal to 50. That is n equal to 50 plus 1. And n is equal to 51. So that is the number of terms in given AP is 51 terms. Now 20th term from the end of given AP is equal to 51. We have totally 51 terms. So 51 minus 20 plus 1th term from the beginning is the 20th term from the end. So that is, as we have 51 terms, then the 20th term from the end is 32nd term from beginning. Okay, 51th term from the end, 20th term from the end is equal to 32nd term from the beginning. So now the 32nd term from the beginning is a plus 31d. Clearly we know that. And by now substituting a is equal to 3 and d is equal to 5. 3 plus 31 into 5 is equal to 3 plus 155, that is equal to 158. So that 20th term from the end of the given progression is 158. Sorry. A 20th term from the end of the given AP is 158. So let's take 16th problem. The sum of the 4th and 8th terms of an arithmetic progression is 24. And the sum of the 6th and 10th terms is 44. Find the first 3 terms of the arithmetic progression. So here also we don't know the values of first term A and common difference D. So to find the first 3 terms of arithmetic progression, we need A and D. So let A be the first term and D be the common difference of given arithmetic progression. And now it is given that the sum of 4th and 8th terms is 24. That is A4 plus A8 is equal to 24. We know that A4 is A plus 3D and A8 is A plus 7D. So that we can write A plus 3D plus A plus 7D is equal to 24. And from this we can write A plus A 2A, 3D plus 7D is 10D. So that 2A plus 10D is equal to 24. Take it as equation 1. And also it is given that the sum of the 6th and 10th terms is 44. That is A6 plus A10 is equal to 44. And we have A6 is A plus 5D, A10 is A plus 9D. That is A plus 5D plus A plus 9D is equal to 44. That implies 2A plus 14D is equal to 44. Take it as equation 2. And 1 and 2 are the linear equations in A and D. By solving these 2 equations, we get the values of A and D. Then after we can find the 3 terms of the progression. So by solving these 2 equations, 1 and 2, in eliminating method, 2A plus 10D is equal to 24. 2A plus 14D is equal to 44. Now subtract the second equation from 1. So we can change the signs here. Minus, minus, minus. Now 2A minus 2A will be cancelled. Now 10D minus 14D, that is minus 4D, is equal to 24 minus 44 minus 20. That is minus 4D is equal to minus 20. And the D is equal to minus 20 by minus 4, which is equal to 5. So now by substituting this D is equal to 5 in either equation 1 or 2, we get the value of A. So substitute the value of D in equation 1. That is 2A plus 10 into 5 is equal to 24. And we have 10 into 5 is 50. So that 2A is equal to 24 minus 50, which is equal to minus 26. So that A is equal to minus 13. Now the first term of the progression is minus 13 and the common difference D is 5. So the first 3 terms are minus 13, comma minus 13 plus 5 minus 8, minus 8 plus 5 minus 3. These are the first 3 terms. Or we can write A plus D, A plus 2D like that also. Okay. So take the 17th one in this exercise. Subbarao started his job in 1995 at a monthly salary of 5,000 rupees and received an increment of 200 rupees each year. In which year did his salary reach 7,000 rupees? Okay, that's the question. So, salary of Subbarao in 1995 is 5,000 rupees, isn't it? And annual increment is 200 rupees. So that monthly salaries of Subbarao year-wise from 1995 are 5,000, and in second year with increment 5,200, and in third year with increment 5,400, like that. And it is asking that in which year did his salary reach 7,000? Okay. So clearly these terms are in AP with first term A is equal to 5,000, D is equal to 200. Okay. Now suppose that his salary reaches 7,000 after n years. That is, nth term is AN is equal to 7,000. This is the first year salary, the second year salary, the third year salary. So that after n years, the Subbarao salary reaches 7,000. That is AN is equal to 7,000. And we have AN is equal to A plus N minus 1 into D. And we have A is equal to 5,000 and D is equal to 200. And now N minus 1 into 200 is equal to 7,000 minus 5,000, which is equal to 2,000. And N minus 1 is equal to 2,000 by 200, which is equal to 10. And N is equal to 10 plus 1 is equal to 11. That is, in 11th year from 1995, that is in 2005, Subbarao salary reaches 7,000 rupees. Okay, students. That's the end of exercise 6.2. In next class, we are going to find the sum of n terms of in arithmetic progression, which is also very important. So see you in next class. Don't miss the next class. Until then, bye.